Today we are going to present a study combining experimental and simulation methods of the assessment of thermal comfort and indoor air quality in office building. As we know, we spend nowadays more of our 90% of our lives inside the buildings. So the assessment of thermal comfort and indoor air quality in office buildings is potential for enhancing health, well-being, and productivity. This methodology, we saw today a methodology that we can introduce that combines measurements and simulation analysis. Here is a flow chart that we saw a little bit what we want to see in the presentation. First of all, we must choose the building we need to investigate. Then we employ the measurement campaign. But in one cases, we combine with questionnaire survey in the buildings that we assess in order to have the particular option of the occupant they use the building. Also, we use simulation tools to assess the indoor environmental quality. And all the measurements that we take from our campaign, we use thermal comfort models and as well chemical analysis for indoor environmental quality to predict the environment of the building. So let's see in more details these two parameters. First of all, as for the measurement campaign, we have the questionnaires, where to measure, where to put our instruments, where to measure, what to measure, which parameters is it that we need to measure according to thermal comfort or indoor air quality parameter, and as well, where to measure inside the building. We must choose one or two offices in our cases, and which characteristics of these offices we must choose. So all this measurement campaign is based on international standard like ISO or ASHRAE, as well as we choose the time interval of the measurement that we use, the time interval to record the parameters inside the building, and as well the selection of the position of our instrument is very critical. And we go, for example, to put it not very close to windows or some sources of heat energy. Continues, the thermal comfort model that we used to predict the thermal comfort is the Finder model adapting model that including the ASHRAE and ISO standards, the most popular models. Then as for the chemical analysis, we must choose if we need to employ active or passive measurement. The chemical analysis will be made after this, and as well as some basic model that we use here in our methodology that combine a measurement that we take to predict ventilation rate, as we will see later. And as well, with all these measurements, we can combine with simulation tools like a building software, ventilation software, or to make some CFD analysis. And one critical instrument is the source apportionment, where we use to indoor environmental quality to predict the source of our chemical compounds. So let's go to the measurement campaign. We have made a measurement campaign at Western Macedonia. We choose 8 different buildings. So we saw today some of our results. We can see here some photos of the measurement we installed at the buildings. We can see here in the central photos some instruments from air temperature, relative humidity, CO2 sedation. As also we implemented passive symbols, passive measurements for VOCs, NO2, SO2, and as well some active measurements for NO2 and ozone, and as well as some instruments to see the particular margins that we have inside the office building. Also, we have a meteorological station outside of the building to see the conditions to the outdoor environment. So this is the main, we put the instrument in about to 5 or 6 offices at each building, but they have different characteristics like the orientation, the number of people inside the building, and the opening they have, like windows or doors. And as well, we give to the workers there a very short survey to predict their comfort themselves in order to take their sensational vote of them after the measurement. So we implement here the Finder model, the most popular as concerns the thermal comfort. So we measure air temperature, mean radiant temperature, relative humidity, air velocity inside the buildings, metabolic rate, clothing level of the occupants, and we calculate two main indices, PNV and PPD. The PNV model, the PNV index is take numbers from -3 to +3 and see how is the thermal environment inside the building. Mentioned here that according to the ASHRAE standard 55, the limits to be in the range of thermal comfort is between -0.5 to -0.5. So with this we can calculate the thermal comfort according to Finder model using the measurement we have made inside the buildings. So here we have select some of our results to present you. We can see that the red lines is the range, the limits of the standards that they said that we have people feel comfort inside the building. So we can see that building 2 is out of the range for most of the offices that we select in the building to invest, while building 1 and 4 are inside the limits that predict we have a thermal comfort. How is this? This is one step to predict the thermal comfort, and then we continue with chemical analysis as concerned to the building. So we have many tools here. First of all, we need to have the theoretical background, for example, to see what to measure, where to measure, and which the tool we have to use. First of all, we can make some measurements inside the buildings, experimental analysis. In our case, we made VOCs measurements and CO2. And as well, we have used some simulation tools, but we'll see after this that how we can connect indoor environmental quality with energy consumption and ventilation. So what we can do is to make experimental analysis. We can use simulation tools. Let's take it all the picture. Okay. So with the experimental analysis, we can make first of all a source apportionment for VOCs. This is a model, a statistical model, but we put out measurements for VOCs, and we can find the sources, the probable sources of our chemical compounds that we have detected inside the offices. And then we can take simulation tools, like what we can see next, to predict the ventilation rates, and as well as we can take the CO2 values to predict these ventilation rates. These two different methods that we compare in the next slide. So if we calculate the ventilation rates, we go to the energy consumption according to the ventilation rate and can compare these different methods. So, and one more thing is that using simulation tool, we can make different CO2 scenarios and ventilation scenarios to see how this change the indoor air quality of our offices. So here we have present some other diagrams for our measurement campaign. Here is a diagram of VOC concentrations. We use passive method, and the analysis, the chemical analysis, we use a GCMS to make our analysis. We can see some basic chemical compounds that we mainly detect under indoor environments, like benzene, toluene, octane. And we can see the difference between the buildings. And then we can continue with the CO2 concentrations in 2 of 8 buildings selected to present here. We can see that CO2 we have peaking during the working hours and dropping significantly when the people leave their offices. And in all buildings, you can see in the building 3 we have exceeds the limits, let's say, about the CO2 concentration. And now we take all this concentration of the CO2, and we put it to a tracer gas method. What is this method? What is the tracer gas method? We can use CO2 as an indicator gas to predict the ventilation rate that we have in our office or building. So this decay method or step-down method can be used when a space is vacated after occupancy. So we take, in these slopes, we implement these methods, the decay methods, to calculate this ventilation rate that we have in our buildings. This is the one method that we used. And the other one is that we use the CODAM, a simulation and polyzone simulation program. So what we do there, we take the geometry of our building, we design the pseudometry in the program, then we put there the openings like windows and door and separate the zones of the buildings. Then we put building schedule like occupancy, CO2 that produced from our users, and as well as weather conditioners that we have in the outdoor space, because this program working with the different pressures and between indoor and outdoor of our building. And then we do some simulation, and we take our ventilation rate and as well some CO2 results as concern scenarios. So we take these results and we can compare as concern the infiltration rate that this building have between the CODAM and the tracer gas method. So we can see that the decay method was implemented in a period when the user left from the office and the CO2 generated is equal to 0. The ventilation frequency of the office different not only from building to building but also from office to office, as you can see in the diagrams. And the ventilation rate, infiltration rate in our case, for each visit is relatively small and less than 0.5 cents per hour. So then we take this infiltration rate that we calculate from the measurement that we made using the CO2 as a tracer gas and the CODAM exchange races, and we put it in an energy simulation program, in our case the design builder, to see the energy consumption that we will have according to different ventilation scenarios. Here we can see the 5 scenarios we simulated in the design builder. The first one is imagine scenario that we have no ventilation. The scenario 3 and 4 is based on the infiltration rate that we calculate from the CODAM, the scenario 2 from the CODAM, and scenario 3 from the tracer gas method. And as well, the scenario 4 and 5 is about that we have opening windows and have natural ventilation inside the building. So we can see here the open windows during some specific period of the working day. That is the option that you select about the scenario 4 and 5. We can see that we have increase of energy consumption between different ventilation scenario 3 and 4, which is a little bit different about the uncertainty that we gave between tracer gas method and CODAM simulation. And as we can see, opening the windows, we can lead into more energy consumption. So closing this presentation, the most important that we need to present you here is that we need to combine to develop a methodology that can combine experimental and simulation analysis. This methodology, first of all, is depending what the building we need to change, we need to choose to investigate. as the type of building is very important. So if we have, for example, a hospital, office building, educational building, is different parameters that we need to concentrate more. And then we go to the method that we need, experimental or simulation method. Our opinion is that we go with the combine of these two methods. As concerns experimental measure, we have the three question where, what, and how to measure this parameter that we need. And what is the model after we use these experimental measurements that we take. And the simulation analysis is according to view what is the necessary, the most suitable software to use for our investigation, and to use experimental data as well. So with two measures you can evaluate the indoor environmental quality, and then this methodology can give some guidelines for improvement to the users, so we can achieve the comfort, energy consumption, and healthy indoor environmental quality. So after the guidelines, we can make then again the measurement to see how this make in the real time and known to the simulation analysis. And all this is to say that, okay, we have simulation to do a lot of things, but it's very necessary to use all the simulation scenarios that we make in the real life, in the real applications like this. Thank you very much.